Hey scholars, I hope y'all are doing great today. I think y'all deserve a little shorter lesson today. So for this lesson on radical equations, I'm only going to work a couple examples and try to get you prepared for our next class. But y'all just make sure you're taking good notes and paying close attention. Let's get started. Scholars, here are a couple examples of how to solve radical equations. You might want to look over these on your slides, maybe after I work through these couple examples. But one thing we want to always remember to check for is to check for extraneous solutions. So these are solutions that we can get from the equation, but they actually may not make the equation true. They actually might not be true solutions. So what we'll have to do is substitute back in, and I'll work an example like that. So don't worry, but we'll substitute back in and we'll see if it actually checks out. And then if it doesn't actually check out, when we substitute in, we have to throw out that extraneous solution. Think extra. It's an extra solution that we don't actually really need. But anyway, so just so you have a little feel for that before we get started, I wanted to talk about extraneous solutions. But let's go ahead and work a couple examples of solving radical equations. So for number one, we have 12 equals 3 times the square root of x plus 4. So the first step I'm going to do is I'm going to get rid of the 3. I'm going to divide out the 3 on both sides. So divide by 3, 12 divided by 3 is 4. And then we get the square root of x plus 4. Now to get rid of the radical, what we will do, since it's square root, I'm going to square both sides because the inverse operation of a square root is an exponent of 2. So I'm going to square both sides. So 4 squared is 16. And then the square root of x plus 4 squared is just going to be x plus 4. That's how we're going to get rid of the radical, by squaring it. And then we can just solve this. Subtract 4. And we'll get x equals 12. All right, so like I said earlier, we want to make sure it's not extraneous. Let's check it. We'll substitute in here. So let's look at the original equation. We get 12 equals 3 times the square root of 12 plus 4. Well, that's 12 equals 3 times 12 plus 4 is 16, so the square root of 16. 12 equals 3 times the square root of 16 is 4, so 3 times 4 is 12, so this checks out. Okay, so we can go ahead and box our final answer, x equals 12. All right, so now let's look at number 2. This will be the last example we work together here. We got square root of 2x plus 14 equals x plus 3. So what we're going to go ahead and do, there's no, like we had over here, there was a 3 we needed to divide out. There's nothing we need to get rid of outside of the radical. Everything on this side is under the radical. So what I'm going to go ahead and do is get rid of that radical. So I'm going to square both sides. And that's going to give me 2x plus 14. That's going to go ahead and get rid of the radical. But we have x plus 3 squared. Now, remember, we don't just say x squared and 3 squared. We're not going to say this is x plus 9. We're not going to say this is x squared plus 9. No, we need to expand it out. We got to say x plus 3 times x plus 3. So we get 2x plus 14 equals, and now we got to distribute this out. That's going to give us x times x is x squared. And I'm going to do this quickly. 3 times x is 3x. X times 3 is also 3x. 3x plus 3x is 6x. And then 3 times 3 is 9. Okay? So if you fully distribute that, you get x squared plus 6x plus 9. Now, this is a quadratic. I want to put it in standard form. Okay, I recognize that it's a quadratic equation because the highest degree is 2. The highest exponent is 2. So this is how I'm going to solve it. Remember, we want to put it in standard form. I'm going to subtract 2x on both sides. And I'm also going to subtract 14 on both sides. So those cancel, we'll get 0 equals x squared, then 6x minus 2x, that's 4x. 9 minus 14, that's negative 5. Now I just want to solve this quadratic equation. If I can't factor it, remember I need to use the quadratic formula. Hopefully I don't have to do that, but let's see. Can we factor x squared plus 4x minus 5? Are there any factors of negative 5 that add up to 4? Fortunately, there are. We can factor this. The factors of negative 5 that add up to 4 are going to be positive 5 and then negative 1. So we get x plus 5 times x minus 1, and we can solve that. Remember, it's going to be x will equal negative 5 since this was plus 5, and x is going to equal positive 1 since this is x minus 1. So x equals negative 5 and 1. Now, we're not done yet. We need to check for extraneous solutions. Let's see here. The solutions I found, I'm going to go ahead and just clear all this off. The solutions I found were x equals negative 5 and 1. Let's see if both of these check out. Alright, so I'm going to substitute them in. I'm going to get the square root of, let's see, 2 times negative 5 plus 14 equals negative 5 plus 3. So I'm just substituting in negative 5. So we're going to get 2 times negative 5 is a negative 10. Negative 10 plus 14, that is 4. So we get the square root of 4. Equals, and then negative 5 plus 3, that's negative 2. Well, square root of 4 is positive 2. And that does not equal negative 2. So we have to throw out negative 5 as a solution. That would be an extraneous solution. Negative 5 is an extraneous solution. Now, you might say, Mr. Pittner, isn't negative 2 squared 4? Well, I can go into this in more detail in person, but when you take the square root of a number, you always go with the positive. Okay, you don't go with the negative. Okay, the square root of 4 is not negative 2. Okay, even though negative 2 squared is 4, we got to go with the positive number. So the square root of 4 is positive 2, which is not equal to negative 2. And like I said, we have to throw out negative 5. It's extraneous. Now let's see if 1 works. Let's see if 1 is extraneous. Alright, so I'm going to substitute in 1. We got 2 times 1 plus 14 equals 1 plus 3. 2 times 1 is 2. 2 plus 14 is 16. So we're going to get the square root of 16 equals 1 plus 3 is 4. Is the square root of 16 4? Yes, this checks out. So 1 does work. So the only solution that works is x equals 1. Negative 5 was an extraneous solution. We found that out by checking. The only solution that works is x equals 1. Okay, so maybe that video was a little bit longer than we hoped. But I hope you didn't think it was too terribly tough. We'll get some more practice with it in our next class. Come to that class with questions and ready to work. Good stuff today. Thank you, Collegiate Scholars.